Hi, everyone. Good evening. You know, this is the last session of the conference, so please bear with us. My name is Mohit Sidana, and together with my colleague Tom Burgman, we are going to present our journey on basically introducing dense vector search or hybrid search into our applications and all the lessons and practical tips we learned along the way. I've been doing search for the last 10 years. I'm currently working as a software architect for the search team in Wolters Kluwer. Maybe, Tom, you would like to talk a brief about yours?
Yeah, I'm Tom Burgmans. I'm a team lead of the search service team in Wolters Kluwer. That's what I do.
So about the Wolters Kluwer, who knows a little about, if you've not heard about us, it's a company where we provide information to the professionals in different domains, like legal, tax, but also in healthcare. So doctors are using our systems to do their online research. We have a set of online research products where search plays a very key role. So where you see all the search boxes, that's the entry point to our systems. The search domain. What we have seen over the years working with the search problems, that there is a common theme. And that common theme is basically this. And I think we all agree on this. AI is inserting itself everywhere. It's not only to build those cool features like RAG and hybrid search for text summarization, but it's also to actually build those features. We are using the AI to do enhanced query analysis, or even building agents to do smart things. At the same time, we come up a full loop. So in our presentation or in other presentations, we've seen that LLM as a judge is also a very hot topic. So it's a full circle. We're using LLM to build things, but also as a judge or generate good judgment sets to evaluate. And it is even more important for the modern search teams to educate ourselves to learn more about how things work under the hood, like dense vectors, because it's still a bit of a black box. You have a bunch of numbers, and you're getting some results. So how we started? Basically, when we started with this research, let me first ask a question. So who has worked on introducing vector search in production-like settings, especially in Lucene-based search engines? So I see a lot of hands here. And then you may have experienced some of these as well. So when we started with our journey last year, we started with the evaluation. And that's basically our first presentation in last year Haystack US, where we tested basically the query and index time performance on the scale. So it's easy enough to build a prototype, but given the scale of things we have to work with, we have hundreds and millions of documents. What does it mean when you introduce vector search? So what are the implications or things you need to take care of? And these are not all, but some of the lessons we learned. For example, every Lucene-based search engine, we have inverted index where you have lexical search, but we also have HNSW graphs where we have those dense vector search results coming in. And all those Lucene indexes have something called segments. So if you have a lot of updates coming into your system, you're always creating new segments, and it has a direct correlation between the performance or the throughput you will get from your search. The other things are like selecting the right K value, because it is a relevancy factor. So high K means you're getting more recall, but it also means that you are adding more latencies into your retrieval, or the impact of filters, especially on the dense vector search, because what we learned is the applying filters can behave very differently if you compare it to the keyword search. On the vectorization side of things, so we've heard a lot about vector dimension and quantization. So how can you optimize for both? And there's a recent addition to that it's not new, but newer models are actually based on something called, let me try to pronounce it, Matryoshka embeddings. And the general idea is that the core meaning of your text is actually in the first part of your embedding. So you can try slicing it or do quantization, and you lose some precision there, but still better to balance that golden triangle where we are looking at the scale. So does it scale, but also can we afford it? So the cost factor and also the quality. The important, one of the other things is the vectorizing the content, especially in our case, because we are getting, we have like hundreds and millions of documents. We're talking about full text articles, but also full books. And when you chunk them, then you have even more, so 3 times more, let's say, the documents. So the bottleneck is actually the vectorizer. So how do you scale for that? And when it comes to vectorizations, basically given a piece of text, you give it to some magic model, and then you get the embeddings back. And there are basically 2 areas where you can go in. So one is the self-managed way. So you have those open source models. There are actually a lot of good ones. It gives you a full control, but you also have to take care of all the things like GPU versus CPU, what kind of machines do you need, do I need to quantize those models too? And then everything what we have here is actually impacting how we are doing, what kind of throughput we are getting, and also the cost. With the self-managed open source models, it's also one of the other factors is the compliance or security. You can also fine-tune them to your own domain, but it also comes with all the other factors you have to take care in. Then we have the third-party providers, so those big AI models where you can just go to an AI provider like OpenAI or Azure, where you can get the model, which is already trained on a very large corpus, but it's not really fine-tuned for your needs. But the 2 things is the throughput and the cost. So what we learned is that when you have a lot of content, it is still sometimes cheaper to run them locally instead of going to the third party, because there are limitations on the throughput, how many tokens you can send, and also the cost is per token. So it's really good for low volume tasks. And since we know the vectorization is actually a factor, which is a limiting factor in our case, can we not reuse vectors, or do we have to vectorize the content with every update we're getting? And the core idea is that in our systems especially, we get a lot of updates. And a lot of times the updates are basically changing the metadata. So the core text is really not changing so much. And we can actually benefit from that because if we are getting the content in our ingestion pipeline, if we have a way to swiftly check whether does it require vectorization or not, we can reuse those vectors, and then also this helps us to optimize the whole ingestion pipeline. And so one of the tricks you can also apply. So that's basically setting up the stage. And now we're going to dive into building a multi-purpose hybrid search index. That's a really cool title, but I'll explain what does it mean. So before I go into why we actually need to build this multi-purpose search index, because we have a long history of implementing lexical search, especially in Solr. And along with that, we also have the whole infrastructure built around that to support the lexical search, like smart query processing. We are doing all kinds of changes to query analysis. And one of the first things you do when you, let's say, want to build a RAG on top of your regular search results, you take your content, you find the best vector database and vectorize your content and send it to the LLM to create the context. But for our use case, it's really not feasible because What we want to do is also avoid is this content synchronization problem. So if we are getting a content for the lexical search, it has to be instantly available for the vector search or hybrid search or RAG applications. So what we started is basically with the research, can we not really use Solr for this? Because all of the search engines, Lucene-based search engines like Solr, OpenSearch, and Elastic as well, have some support for vectors. So you start building the index. The first thing you need is basically these fields. And then the field type, which is the dense vector field type, where you specify some parameters like the number of dimension, what kind of similarity function do you need, and the encoding. And for this purpose, we chose the nested document structure. It's basically an existing feature in Solr, where you have your full documents and then the chunks. And then you can create this nested parent-child kind of relationship where your parent document contains those nested documents, which are basically the chunks and the embeddings. And then there's a link where it says the child document is actually has the parent ID. And what it does allow us to do is basically, by the way, before I jump into that, what we learned here is that you can also optimize this. So like stored equal false, that means these vectors, we do need them for search. We don't need to store them in Solr. So that way you can also minimize the whole disk space and then the amount of memory you need. But also the quantization, like Solr supports float 32, which is 4 bytes, but you can also do this with scalar quantization, so that's int age, so you go from 4 byte to 1 byte, and that also helps us to minimize the whole impact on Solr. And once we have these documents in Solr, in this nested structure, we can actually reuse them for multi-purpose. And the search index is basically suitable for RAG. So we have chunks. You can do a hybrid search on the chunks, lexical, both vector, and then you get the chunks back. That's your context for the LLM to generate the answer. Sorry. But you can also do a hybrid search here, which is the lexical search on your full document, but also vector search on your chunks. And then you return the full documents back. And that's basically the regular search results. And it is actually possible to do this in Solr. So we know when we started with this, that Solr has some limitations, like it doesn't natively support hybrid search. But for our use case, we came up with this query syntax, which allows us to do both. So for the RAG use case, where we have this Boolean query, and then you have a keyword query, and then also a vector query. And then the relationship between those two is an OR, because should here. And the way the keyword query is basically the typical edis max query, and in this case, it can also be the analyzed query. And then you have your vector embedding, which is externally vectorized. And there is a scoring function which takes the keyword weight and the vector weight, and then you can also control how much impact each section has, so you can tune it. And what it allows us to do this combining of the scores. So this is our variant, but there are other variants possible, so you can also, instead of summing them, but you can also multiply it. There is also a possibility to use a scale function here, so to normalize the scores for each side and then combine them. But we learned that the scaling on a large data set is not really useful for us. And then the classical search side, we have used this block join query parser because we have those parent and child documents. So we can also do a regular edis max search for the lexical part, but we can also do this child query, where we are searching for child documents by vector search, but what we get back is the full documents, and that's basically the hybrid search. So now we have sort of a solution for both RAG and for the hybrid search. And the index is there. Are we done? Probably not. And I think I'd like to invite Tom to talk about the next set of challenges which comes with implementing hybrid search in Solr.
All right, thanks, Mohit. And special thanks to Alessandro Benedetti, who inspired us with this kind of syntax. It is pretty hairy, but it works, and it is actually understandable if you dive into it. So let me go to the next slide. Let's talk about relevancy tuning. There are multiple definitions of what relevancy tuning is. The small definition is that you are tuning matching, and you're tuning the algorithm that scores. Right? And then that's already a big world, because you can do a lot there. You can do the text analysis. You can match fields, balance fields against each other. You can apply synonym expansion, different kind of query expansions. You know it probably, right? Now, doing that, the broad explanation for relevancy tuning is way more than just the ranking of the results. It comes with the complete search experience. So think about keyword and context, the way how we do highlighting, the autocomplete, spell checking, facets, the whole thing that makes a user to consume search results. So doing that for lexical search alone is already an art and a science in itself, and that was back in the old days when life was still easy. You remember that? Nowadays, it's becoming more complex with vector search coming into the mix. And it's really a difficult mix. I usually compare that to two substances that don't really mix very well, like water and oil, because those two ways of retrieval are so different from each other that trying to blend them together is just a very hard job. Lexical search is basically exact matching with some scoring. Vector search is an approximation. That's already different. The ways how the scoring is calculated is totally different, works on different scales. And of course, you can normalize them, but even then, you don't know for sure if like a score of 0.5 on both sides means the same kind of relevance. We have a lot of debug information here that explains how the score is being built up from a lexical search, but doesn't exist on this side. So we're pretty much blind here in terms of an analytical way analyze what happens here in terms of steering the vector search relevancy. Boosting. You can boost the entire result set with lexical search, but you can only boost the top K results on the vector side. So there's limited impact there. Number of results can range here from 0 to the entire result set, and from here it's basically always K. That's sometimes an exception, but K is basically always it. So how can you do that in a more effective way? How can you blend that together? That's the big trick here. And it's getting even more complex. So relevancy tuning today is not just tuning for humans anymore. We actually also tune for machines. Right? So how do they differ from each other? For humans, they tend to like to consume full documents. But LLMs, agents, they like to have only those fragments of documents that contain the complete meaning, contain the meaning, but not all the other, let's say, junk from the same document. So that would be much better for them to consume. The way how both of those parties consume the search is also different. Here, humans like to scroll, they like to see the keyword, they sometimes facet more, they use pagination, but LLMs, they only like to see the top and chunks. And it doesn't even matter in what way they are ranked. Well, some say it does matter, but humans like the best result on top, position number 1. LLMs, it just matters if the content is part of the top N that it gets, right? It also matters, by the way, if there is noise inside. So, and as a side note, tuning for LLMs, we noticed that sometimes you can give an LLM perfect search results, and then it still generates a wrong answer. It can also happen that you give it good search results and some noise results, and then you think you're done, but it's not really true, because it maybe generates a good answer, but it refers the wrong results, right? And that can also happen. And in our world, it's really important that if GenAI is giving an answer to a user, that the good references are also put in there, because that's, in the end, just as much as value as the answer itself. Right. The tuning goals for humans, the actual goal for is to make the human happy. Happy humans tend to pay more. For LLMs, it is more necessary to create that it, that it creates factual information. Right, so that's again different. So I could say for a relevancy engineer, the world is getting way more interesting after the introduction of vector search, and the fact that we now do it for both Gen AI and for humans. Okay, so when we have two ways of retrieval, lexical and vector match, we have to balance how much each of those contribute to the final score. And the best way to do that is to actually analyze the query and to figure out what is the impact that both sides should have. Now, there is a category of queries where you can say, well, even if we say, please do hybrid search, we skip vector search nevertheless. For example, most obvious one, if you do a star search means just return me the complete index. A lot of users do that. They just want to have everything back, and then they start to select using the facets and drill down to their results. So in that case, doing vector search doesn't make any sense, because there's just no meaning from that star search. But there are other cases too, like Boolean constructions or explicit proximity searches or phrase searches, or those kind of categories where searching for a particular word or a combination of words still really matters. Right? In that case, you can still say, no, let's not do vector search. It doesn't do any good. It just adds noise. But there's a whole category of queries where vector search actually does add some value. We have still some queries where keyword search should be very dominant, like a citation. A person looks for a particular thing, knows what the thing is called. Citation is kind of a group name for different kind of identifiers that a lot of our users put in for some documents or some cases. And in that case, the user really knows what this person is looking for. So lexical search should still be very dominant there, or case nicknames. But the more natural language you add to the query, the more vector search starts to get an important role. And the most extreme case is, for example, if a user types in or copy-paste a complete summary of a certain case using different words, but just looks for that document that has the same meaning, just in different words. Okay, so what we need is something that interprets the query and that can make some balanced decision what to do right here. It's almost like we need something like this. Right? Something that takes the query, maybe the history of the query, some context or other context, figures out what to do, and then spits out the weights of both. But we don't even have to stop at the weights. You can do way more things than just weighting the two parts of our retrieval process. You can also apply filters or specific boosts, rewrite the query in some kind of ways, expansion. Bottom line, I think there will be a lot of additional effort in the future where we can spend our energy on in order to make this one better. And it is not that we don't already have a query pipeline that interprets the query and plans it out. But I think this is a start, and the introduction of vector search makes it even more interesting. This is where we will spend a lot of time in the future. I can imagine that it turns out to become much more of an agentic system after all. I also see a big role for small language models, very tiny, local pieces of AI that are inserted in our query interpretation that are, optimal for that task, very cheap, very fast. Maybe we will detect that wormholes do exist, and we can, do all kind of fancy things there. So maybe for next talk we have some additional material to talk about. All right, so let's talk a bit about how to introduce hybrid search in a large organization. So the next slides are dedicated for that situation. Maybe it resonates more if you're also working in a big enterprise. So when we had to introduce this, right, to a large organization, it happened basically at the same time when GenAI started to get mainstream. That is not a coincidence, but it was around 2 years back that it became really supported in Solar, where we started to experiment with this. Everybody probably has its own version of how GenAI or the AI world took over, your professional life. In our case, it really happened basically as a storm, and it's still happening. Especially in the beginning of those years, it was not a very well understood phenomenon, still not is. But there was a big realization that everybody wanted to jump in that train, want to get on board, to do something with AI. We don't know really what it means. A lot of high expectations, the sky is the limit there, but not very well understood. And AI is not search, right? A lot of people still think, and back then thought, that AI is kind of a separate world, and then you have search. Search is the old way of retrieval, then the AI is new. And that the worlds are very much entangled is not very well understood always. Right? So search currently is powered by AI. Vector search has an AI element. But to do good Gen AI, you need also good search in order to give you a good context. So what happened is that a lot of investment or energy went into the AI itself, not so much search. So that is, why would you want to listen to somebody telling about vector search when there's something way more spectacular as Gen AI that just generates the answer? So all of these quotes are coming from talks that we had in the past, like, will AI replace search? I don't think I think that's a nonsensical query, but I can understand if you don't really live in the world of search that this is something that you start to wonder, right? Search is not developing anymore. Like, okay, it's old-fashioned way of retrieving. Now we have Gen AI doing all of this. And why not just train a model? Right? That's somebody asking. There is even a school of thought that thinks that the future AI systems are getting so powerful that you don't even need search for that. Like, maybe it can consume the complete index as context, and then you have it all. You don't need a retrieval system anymore. You just let it based on that context. I'm not sure if we are getting there, but maybe it's not a weird thing to think about. Right? What if AI is so powerful that it can consume the complete index as context, and you don't need to search? Okay, but we had to introduce this in our organization, and the way how to do this is basically a bottom-up approach, because we as a search team, we bumped into vector search, and we were convinced that this will play a big role in the way how we do retrieval. We believe this is something that our product owners need, and we had to convince them. So the way how to get that is to start a campaign and explain with presentations. We participated in all kind of hackathons. A very powerful way of spreading a message is to create short videos of 1 to 5 minutes maximum, very well created, very slick made, that explains and pitches the idea of hybrid search. But it was a bottom-up approach. It didn't come by itself. We had to explain that this is something useful that most product owners probably need, even though they don't know it yet. All right, so the first goal is to get parties interested. Once we have some interested parties, we could create prototypes and showcase that it actually works, and even showcasing it with their content. Important for prototyping is not just showing it, but let them experience how it works. So it is campaigning all the way down. Education is also necessary. We have to explain what it can do, also what it cannot do, also where the pitfalls are. I have a couple of slides more on that. And we have to get early aware about the cost, because it's not free. Right? It comes with a price. And then, even if they are not discouraged yet, you can go to something more serious, really build a POC and integrate it in their systems and you know, basically showcasing it that if this works, then it is ready to move it to high environments and go to production. So productionization, yeah, that's where we introduce it to end users for the first time. And the idea is to start small, learn our lessons, verify, A/B test, and then grow from there. Right? And then 6 is actually getting mature in production where hybrid search is getting the new normal. And I must say, we are not there yet. We are kind of here in this space. So there's still a lot to learn. Right? Okay, so something about the cost. At some point, you have to get honest to product owners. Yes, it will cost you. It's not for free. Now, these numbers here, this is a bit of a kind of put out of the air, but not really, because it really depends on how you're going to create your hybrid search implementation. But the main story here is that most of the increased costs are expected at infrastructure here, at least in our cases. Because creating a vector index is expensive. You have your big vectors there. Even though if you quantized, it can still add a lot of space. And you need to load the complete index into memory, opposed to lexical search, where you can go fine with just having a portion of the index into memory. Vector search, not so much. It has to be all there in memory. So your infrastructure costs will blow up, probably. And we think that that's the highest cost. Though development and tuning, I mean, also that is big. Factorization, though, sometimes gets all the attention because it's a very brand new cost factor, which was not there before. It's either self-hosted or it is commercial, but in both cases, it's additional cost. But it's not so much. Right? Compared to the others, it is relatively low. And also to put this in perspective, it is not a complete picture of the complete product development. It's only there where the costs are rising, but as for a water product, many other buckets of cost which is not part of this picture. So we should also put that in perspective. It's not that all the costs will double in development, just the search piece. Okay, let's go to prototyping here. So I explained that it is necessary to have a very clear prototype to tell the message and explain to product owners why they need it. Right? And this is an example of a prototype that we've built. It is pretty dull looking, but that's done on a purpose. So it's only a search box, a bunch of search results, and that's it. Right? But the reason why we made it like this, not fancy at all, but just clear, is to emphasize the fact that we are looking at hybrid search results with interlaced search results, both from vector and from lexical matching. And it is, by the way, amazing how much overlap our talk has with other talks that we had before. So we just saw the one from Otto, background colors, exactly what's happening here. All right, so we made clear with background colors what the origin was of a search result. And for blue means it's a lexical match, green means a pure vector match, and when it's gradient, that's both matching from both sides. And the way how you could achieve that is by adding a piece of syntax like that on to the query. If you go back to slide 9, it refers to if you use that syntax and use this one as well as in the FL parameter, then Solr will tell you what the origin was of the match, whether it was vector, lexical, or both. And also notice this slider here on top. This is obviously not something you would like to expose to end users, but it gives product owners the idea that this is tunable. So they can tune themselves. Right? And this is a slider that let somebody define whether a keyword match should be dominant or vector match should be dominant or something in between. So you just slide it, and with the same query you get different results, and that is nice for experiencing. So this really helped in order to get that message across. Okay, then some items that need to be explained. I thought education is really necessary. also to pinpoint at some, side effects which may be unexpected once you go from lexical world into a hybrid search. And this is one of those things. So document counts and facet counts. And this applies to the way how we implemented hybrid search, which is this OR construction between lexical and vector. If you do it in another way, for example, by re-ranking, then I don't think that you have that side effect. But in our case, the way how we implemented this is a side effect. What's happening here? You search through the query, and then the facets appear on the left side, right? And there are facet counts here. So what happens in a lexical word, if you click that facet, it will return exactly the amount of documents that count indicates. That's what the user expects. I click this result, I would see 866 results back. But we are talking now a vector search, right? You click that result, you click the filter, and then suddenly there are more items in the filter than were there before. So how is that possible? That is possible because the moment I click a filter, it does filter there, but it also generates new vector search results which were not there before. Right? I said before, there's always k results that come back from a vector search, no matter how deep we scope or how broad we query. So these are new vector search results which are not part of the initial result set. So it's really difficult to explain sometimes to product owners that this is expected behavior. It's not a bug, but it looks weird and it's counterintuitive because you're zooming in and you're actually getting more results back here. Right, so that is something to explain. There are possibly ways to mitigate this, but it introduces other problems. One way to mask it is to not show the facet counts at all. That can be a solution. But can also maybe not acceptable because some power users really like those intuitive numbers there and they don't want to miss it. Right? And I can understand that too. Maybe there's another way to just remember initially all vector search results from the first query and apply that as a filter. Once somebody clicks this filter, apply that as another filter on top of this, just to make sure there are no new vector search results back here. We're just filtering with all the doc IDs from the initial vector search here as well. So that may work. We have to see if that's possible to do. But it introduces a state between those two queries. And previously we had a stateless implementation of a search engine, and that would be not the case anymore. So the moment you introduce states between multiple queries here, there are multiple queries, we come into a different kind of problem space. But anyway, maybe this is some area that we need to dive into. If it turns out that this is going to be a deal breaker for those product owners that don't want to have this behavior. All right, and then a sudden end to the story. And this is, we don't again full circle with a nice story arc. We just end it suddenly abrupt. But it's kind of indicative of the way where we are right now. So we are in the middle of this journey. It has just started. We are not done yet. We have learned a lot, but we still have a lot to learn as well. So, you can ask us anything. Let's see if we can answer it.
Yeah.
Thank you.
And I think I would like to add, we are open for also any feedback you have on any of the things we are doing.
Thank you for these practical insights. So I'll start off with a question from the online audience. As a rule of thumb, what would be the number of documents where you would prefer to move from third-party to self-managed setup?
Yeah, that's a very good question, and I wish I had those numbers available. We did do those calculations, though. So indeed, I had this task in order to come up with some kind of a breaking point, and I wish this question came earlier to me because I would have those numbers available. But yeah, there is a breaking point. It, of course, depends a bit on the factors that you have. So, but again, I still think looking at that cost picture, we shouldn't focus too much on the cost for factorization. Just choose what is most practical, what performs better, and those are, I think, in the end, a bit more important than trying to save cost on that little box of factorization. Because infrastructure is way more, and development and all of that.
Yeah, and I think what matters there most is the throughput you would like to get. Because if you're running it self-hosted, then you can horizontally scale it. It is still possible to do that from the third-party providers, but there are some limitations there as well, like how many deployments you can have in single region or multiple regions.
Mohit, Tom, thank you so much. I'm not sure, just maybe for the purpose of the bigger audience, that people understand how much content you guys have, right? I think it's not, classical, let's say maybe e-commerce index or something, right? So maybe it would be good just to reiterate, I don't know, at least approximately what number of content do you have, because I think that explains why certain decisions needs to be made, but this is not a question, it's just a feedback on this one. And more of a question, for me, Solar, obviously, and I think for a lot of people in search communities, like one of the first, kind of love or something, Lucene maybe or whatnot. However, we'll see like the shift towards, I don't know, OpenSearch, Elastic, Vespa, and whatnot. So how do you guys feel about Solar in, let's say, 2025, especially with dense vectors? You've shown how it's possible. Alessandro obviously did a great job helping you with like some of the block join query stuff and whatnot. Just what's your opinion, thoughts on that in 2025? Thank you.
Let's start with the content. Yeah, content. So we don't have trillions of content, but so our larger products have ranging from 10 million to 100 million documents, but those can be big. So we have large pieces of documents, and we're dealing with big pieces of unstructured text. If you start to chunk them, then you can really blow up the amount of documents suddenly. Right? So, but we also have tiny parties. We have a lot of separate indexes, different use cases, where we have just ranging from a couple of 10,000s. Those are small, but yeah. The bigger ones have 10 to 100 million documents. So that's a bit of the range. I don't think we got much higher than 100 million in terms of large documents. The other question, how do we feel how Solar is doing this? So yeah, I think Solar is doing a good job, actually, right? Because it follows the scene. It is maybe not the earliest adopter in terms of all the features. I think Elastic, OpenSearch are a bit more to the front of this. But we have a long history with Solar. We have invested a lot of knowledge in it. And so far, we don't see a reason to switch, because Solar does the things, even though it doesn't, for example, support barbecue or bit quantization or a couple of things that some other engines are a bit further away. But it does do the job, right? And therefore, we can do this. And doesn't mean we are married to Solar. We are exploring other options too. We have always keep an eye open, but so far it doesn't give us any reason not to go with full force with this.
Next question from the online audience. Can you elaborate a bit how to handle filters, for example, pre-filter or post-filter, depending on your search stack? For example, Lucene allows exact filtering during search, but other engines don't, and this hurts recall when many filters are applied.
Can you say it again? Because
I guess it's related to the faceting that you showed. So can you elaborate a bit how to handle filters, pre-filter or post-filter, depending on your search stack?
Yeah, so we always do pre-filtering, right? So there is no use case for post-search filtering. The pre-filtering means that we are actually, if it's about vector search, while traversing the graph, it is already filtering out the results that it shouldn't get. So we don't first retrieve all documents from the vector search and then select what you not want to show. So I'm not sure if that is answering that question, but
I assume so.
There's this question, if there's pre- and post-search filtering, we only do pre-filtering, in fact. Yeah.
All right, good, thank you. Is there one last question from the audience here?
It's not a question, just a comment. Like the question was about, and you might have remembered from yesterday, when you start pre-filtering, like the vector space gets really disconnected. So while you traverse the HNSW graph, you might not locate some documents. So that to some degree hurts recall. So you might have to like over request when you start filtering.
And I think we agree with that because in our last year presentation, we explored what is the impact of filtering on dense vector search in Solr. And that time we couldn't really explain when we were doing this experimentation that what is really driving these latencies. But it's basically when you're traversing the graph, these holes, it's actually responsible for that. But also the quality, because once you start having this disjoint between those graph nodes, where the Lucene-based search engine or HNSW graph traversal really struggles. And I think we don't have a solution for this yet, but we're still exploring this. So hopefully in our next talk, we'll have a solution for that, or at least the answer.
Definitely sounds like we'll have another submission by you two for next year Haystack EU. Okay, great. So one last round of applause.
Thank you.